I think I probably was just most excited about science as a little kid. I think I just had a natural fascination with the things around me. Like looking at oil and water and wondering like, why don't these mix? Like they're both liquids, so what's going on? And then as I got older learning like, oh, chemistry can explain a lot of those cool things I was seeing. So I think that's sort of the root there. So my high school chemistry teacher, Mr. Vernon, he was just phenomenal. A lot of the STEM courses early on that I took were with him, and he sort of taught me how to be excited and engage with difficult material in a fun way. And that sort of started there, and I've loved it ever since. The reason I was interested in this lab to begin with was because I wanted to do some sort of environmental work and work that would have an impact on people ultimately. There's tons of good research out there that is sort of pre-application space, but I wanted to do something that I know would have a direct impact on the community. I would define my work as developing methods to measure PFAS in the air in real time. PFAS, for anyone who doesn't know, are per and polyfluoroalkyl substances. Basically, they're just compounds that have lots of fluorine in them. So right now we have a few ways that we can measure PFAS in the air, but they're not in real time, so it takes around a week or maybe even a month to be able to actually get a number from when you start the measurement. And I'm trying to figure out ways that we can get measurements instantaneously. There's not really a lot of data available right now about inhalation exposure, and that's due in large part because we don't have measurements of PFAS in the air. So that's sort of where I'm trying to come in and make measurements of these compounds in the air so that we know what we're breathing. The advice that I would give to my high school self is to talk to people more, especially people that don't do what you do. Some of the best ideas I've got for research come from talking to people who know nothing about chemistry, and they ask me something, oh, can you do this or can you do that? And at first I think that is crazy. They have no idea what they're talking about. And then you think about it more, you go, oh, actually, you could do that. And then you go in and it works really well. So I think getting different perspectives is always great, and the best way to get a different perspective is to talk to people. Being a member of the LGBTQ+ community in STEM is not as scary as I anticipated. I think that there's actually quite a few LGBT people in the STEM community. It's very accepting, I would say, and I was definitely more worried than I should have been. I think one of the most sort of rewarding aspects of what I do is that I get to figure out what the story is. That's really what I enjoy doing. So I come into lab with my questions, and then it's my job to find the answer. And I sort of get to direct how I do that. So there's a lot of freedom in STEM, I'd say, and that I get to design my own experiments, carry them out, and then look at the results and sort of share that with the rest of the world.